Software versioning is the practice of assigning unique identifiers to different releases or versions of a software application. These identifiers, often in the form of numbers or strings, help developers and users keep track of changes, improvements, and updates made to the software over time. Versioning is crucial for effective collaboration, communication, and troubleshooting in software development and maintenance. The most common forms of software versioning include 1. Numeric versioning, XYZ. Major version, X, incremented when significant changes or new features are introduced, and these changes might not be backward compatible with previous versions. Minor version, Y, incremented for smaller changes, additions, or enhancements, usually with backward compatibility maintained. Patch version, Z, incremented for minor updates, bug fixes, and patches that do not introduce new features or change existing functionality significantly. 2. Semantic versioning, same-where. A specific versioning scheme that follows the format major.minor.patch, and it also includes optional pre-release and build metadata tags. Semantic versioning aims to communicate the nature of changes through version numbers. Major, as in numeric versioning, incremented for incompatible changes or significant updates. Minor, incremented for backward compatible new features or enhancements. Patch, incremented for backward compatible bug fixes. Pre-release tags, optional identifiers for versions that are not yet considered stable, often indicated with labels like alpha, beta, or RC, release candidate. Build metadata, additional information, usually in the form of a build number or commit hash, to help uniquely identify a specific build. 3. Date-based versioning. Some projects use dates as version identifiers, reflecting when the version was released. This approach is less common but can provide a clear understanding of the age of the software. 4. Alpha, beta, and release candidate labels. Instead of or in addition to version numbers, software releases can be labeled as alpha, early development stage, beta, testing stage, or release candidate, almost ready for final release. These labels indicate the level of stability and maturity of the software. 5. Internal versioning. In addition to external versioning for users, software projects often maintain internal versioning to keep track of development milestones, branches, and internal builds. Versioning is essential for various reasons, including clear communication. Users and developers can easily understand the significance of each version and its changes. Compatibility. Version numbers help identify which versions are compatible with each other, ensuring smooth integration. Support and maintenance. When issues arise, specific versions can be identified for troubleshooting. Documentation. It aids in maintaining accurate and comprehensive documentation for different versions. Software lifecycle. Versioning helps in managing the software's life cycle, from development to release to maintenance. Choosing the right versioning scheme depends on the project's goals, development practices, and the needs of the user base.